Today in class, we learned and talked about time as measurement. And your problems that you are going to be working on for the next few days have to do with elapsed time, or the difference between two different time events. So in our minds, we're thinking about doing subtraction, but the standard algorithm doesn't always work when we are looking and working with time. So today we discussed how we can use the differencing strategy on a number line or the removal strategy. If we're presented with this problem, a runner finished a race at 10:15 a.m. It took her 55 minutes to run. What time did she begin? So I'm going to draw a number line, and I'm going to put the information that I know. I know that she finished at 10:15. Which means I also know that I'm going to be moving back in my number line to a time that she began, which occurred in the past. To do that, I also know I need to move back 55 minutes. We all may have different strategies for this. I'm going to start with the friendly number 5. And I'm going to move back 5 minutes, which would take me to 10:10. And then have a couple choices. I could move in increments of 10, or maybe I could move in increments greater than 10. I'm going to start by moving in increments of 10. So I'm going to go back 10 minutes, another 10 minutes, another 10 minutes, now I've gone back 40 minutes, and I'm going to go back 50 minutes. So I've made my jumps. I jumped 5 minutes, 10, 20, 30, 40, 50. So I've moved back 55 minutes. I now need to subtract 10 minus 10 minutes would be 10 o'clock. 10 o'clock minus 10 minutes would be 9:50. It's 9:50 minus 10 minutes would be 9:40. 9:40 minus 10 minutes would be 9:30. 9:30 minus 10 minutes would be 9:20. Another way I could look at this, I have my number line. I know that I start at 10:15. I end at 10:15. I need to move back 55 minutes. I could say, well, you know what? I'm still going to jump back by 5 minutes because that's going to get me to 10:10. I know that if I jump 10 minutes, another friendly number, I'm going to get to 10 o'clock. Now I'm going to jump 30 minutes because that's a faster, will get me to my end result faster. So 10 minus 30 minutes will be 9:30. I need to check how many minutes I've accumulated. 5 plus 10 is 15. 15 plus 30 is 45. So I have another 10 minutes to go. Take away 10 minutes, I'm going to be at 9:20. Here I've shown how I can use the number line to answer this question. Tonight on your homework, on page 152 of the student book, there's a question on the Preparing to Race page that asks you, Jacob woke at 5:50 a.m. on race day. He got ready in 35 minutes and drove 15 minutes to the event. Will he make it to the race for the 6:45 start time? I'm going to get you started on this problem, and tomorrow in class we'll go over it more. We're going to use the differencing strategy for this. So I'm going to draw my number line. I know that Jacob woke up at 5:50. I know it took him 35 minutes to get dressed. So I'm going to say, okay, I know I need to add 35 minutes. If I add 35 minutes, get to 6:25. I could break this down into smaller chunks. I could say, okay, I'm going to break this into 10 minutes. That would get me to 6 o'clock. Another 10 minutes, get me to 6:10. Another 10 minutes would get me to 6:20. Another 5 minutes would get me to 6:25. Then I know it takes me, Jacob, 15 minutes to drive. So I'm going to jump another 15 minutes. 6:25 plus 15 minutes would get me to 6:40. Now you have to decide, will he make it to the race for the 6:45 start time? And you need to explain why you know he will or why you know he won't. That's 2 models for how to use strategies to solve elapsed time problems.